Welcome to this explainer. Today we're diving into the dark, kind of mysterious world of Sentry performance monitoring. We are not just going to talk about theory today. We're going to put on our trench coats and do some real detective work to solve pretty much every developer's worst nightmare.
Picture this. You get that incredibly vague, notoriously frustrating user support ticket. It just says, the checkout page is slow. That's it. No screenshots, no error codes, just a really annoyed user and a silently struggling system.
So, where do you even start looking? I mean, when an app crashes, right, it throws an error, gives you a stacked trace, basically waves a massive red flag telling you what broke. But sluggishness? Sluggishness is totally silent. You're flying blind. How do you investigate this without just, randomly clicking around your infrastructure, hoping you bump into the problem?
Let's open up the Detective's Toolkit and look at APM versus error tracking.
There is a huge shift in how we need to approach observability here. Look, traditional error tracking is brilliant. It captures exactly what broke using stack traces. If a function throws an exception, you know about it. But Sentry's performance monitoring, it's a completely different forensic toolkit. It skips the broken code and actually shows you where and why the system is dragging, usually way before it turns into a full-blown critical outage.
Moving right along to the anatomy of a request, the telemetry hierarchy.
Think of this like a set of Russian nesting dolls. The biggest doll, that's the trace. This is your macro-level view. It tracks the entire end-to-end journey of a single user's request as it traverses across your architecture. A user clicks buy, and the trace follows that exact action from the front-end browser, straight through your API gateway, deep into your back-end microservices, and all the way back.
Pop that doll open, and inside we have the transaction. A transaction is basically a specific major event happening within that broader trace. It could be a page load, a particular API request, or in our case, the checkout operation itself. It gives us clear, distinct boundaries for a piece of work.
And finally, inside the transaction, you'll find the span. The span is our smallest clue. It represents a single, discrete, timed operation. We're talking an individual database query, a file operation, or a network request. Whenever you see a massive latency spike, this is the granular level where the culprit is usually hiding out.
All right, let's get into profiling the suspects with latency percentiles. Here's the thing. To find our culprit, we cannot just look at average response times. Averages lie. They completely obscure the experiences of users at the margins. You need statistics here. So your P50, or the median, that's your typical user baseline. P75 is the gold standard for core web vitals. But for hunting down a sluggish checkout, you absolutely want the P95 metric. That's the key. It focuses all our attention squarely on that agonizing tail of the distribution, the slowest 5% of outlier experiences. And believe me, when a user complains, they're almost definitely living in that P95 tail.
Now we dive into analyzing the evidence, the transaction waterfall.
Here is exactly how we hunt this down in Sentry. First up, filter your checkout transactions strictly by that P95 latency. Next, you pop open the TraceView timeline for one of these painfully slow events. Sentry automatically helps us out here. You just look for the suspect spans that the system already highlighted. Finally, isolate the operations eating up a ton of self-time. That's the time spent executing that specific span, not just waiting around for its children to finish. Zooming right into this waterfall chart lets you visually pinpoint the exact millisecond your backend starts to choke.
And boom, here's the dramatic finding from our trace view. 10, a massive latency spike showing that this specific checkout transaction took an agonizing 10 seconds to complete. I mean, just imagine staring at a loading spinner for 10 full seconds while trying to give a company your money. It's a literal eternity.
But here's the magic. We don't just know it's slow, we actually know why. Sentry's automated problem detectors flagged a specific suspect span deep down in the database layer. The culprit? An N+1 database query.
Sentry span evidence lays it all out perfectly. 17. A single checkout page load triggered 17 identical, redundant database queries fetching data sequentially. So instead of just asking the database for all the cart items at once, the code was looping, asking the database over and over and over again.
This creates an absolute massive performance roadblock. The N+1 query problem is a total silent killer. You have multiple sequential database calls, and you are incurring the network latency and processing overhead for every single one of them. It causes complete linear performance degradation. The fix is so simple though, a batched query.
It's a single, consolidated call that grabs all the necessary data at once. It's incredibly optimized and way faster.
Let's wrap this up. Closing the case. Resolving the slow checkout.
Think about how fast this was. In just a few clicks, the support engineer went from a super vague, "it's slow" complaint to a precise diagnostic. They filtered by P95, identified the slow transaction in the waterfall, located the N+1 database query span, and check this out. Because Sentry links all this back to the code, they sent the exact line of code triggering the loop directly to the dev team. No spending hours trying to reproduce the error. Just boom, here's the broken code.
The real-world resolution? The developers saw the evidence, swapped out those looping queries for a single batched API call, and literally slashed the checkout time by 75%. The timeouts were entirely eliminated.
And honestly, this is why all of this deeply matters. As one of the sources pointed out, if our app is slow, users won't wait. They'll just leave. Shifting your mindset from reactive troubleshooting, like sitting around waiting for crash reports, to proactive observability using performance monitoring, that directly saves your user experience, and at the end of the day, your revenue.
So, I'm going to leave you with this final thought. Are silent database bottlenecks driving your users away right now? Averages might be telling you your app is perfectly fine, but your P95 tail could be hiding an absolute disaster. It might just be time to open up your own transaction waterfall and see what the evidence actually reveals. Thanks so much for joining me on this explainer, and happy hunting out there!